notice there's something happening to the x other than, it's okay that it's being multiplied by a -1. That won't stop this from being linear. But the fact that it has an exponent on it other than the invisible 1 exponent, that tells me it's non-linear. Right? That right there tells me not to expect a straight line graph. Now, again, from past experience, you may know what a 2 exponent graph looks like, but we haven't reviewed that yet. So let's just plow ahead with making an XY table. So suppose I put in 0, 1, and 2. So I'll have -0 squared is just 0, -1 squared. Remember, when the x is not in parentheses, so I'm not squaring the whole, I'm not squaring the negative, right? That would have to be indicated with a parentheses that include the negative. So this is just -1. I'm just trying to remind you that when you write a squaring like that, the squaring does not affect the negative sign. Okay, so plotting those, I have 0, 0, 1, -1, 2, -4. 1, 2, 3, 4. Okay, so yeah, those aren't quite in a straight line. They're in some sort of a curve. Now, I don't know what happens over here. Does the curve continue? So if I just connect these, I have something like that. Okay, should I just kind of continue the curve? Am I going to have something like that? I don't know. I need to plot more dots. So as soon as you get away from linear equations, 3 dots may not be enough. So let's actually put in some negative x values and see what we get. So -1, -2. Let's use those. Okay, and I'm going to continue to write out computations because these are a little tricky. So -x squared can be represented as like that. So my advice for you, if you're having any trouble getting the correct y values, is to rewrite your equation, replacing the x with empty parentheses. Notice the x is the base on the 2, so the empty parentheses are the base on the 2. In other words, the 2 is not inside the empty parentheses. And similarly, the minus is in front of the x, so it's in front of the empty parentheses. So what am I putting in for x in this line? -1. So -1 squared is +1, and that minus comes along for the ride. Here, again, to compute -x squared, a technique that can help if you're having trouble with this, again, is write negative, empty parentheses squared, then put in the x value you're using. I'm using an x value of -2, so -2 in parentheses squared is +4, but that minus sign is coming along because this squaring doesn't affect it, so I get positive -4. Okay, so plotting those dots, -1, -1 is down there, -2, -4 is down there. So, good thing that I made some dots here for the other side, because the curve doesn't just continue, it does something a little different. It does something like that. Okay, so that, no, is not correct. Okay, so as soon as you get away from linear equations, it's very difficult. Now, if you know about the shape of these x squared graphs, you're probably laughing at me for naively continuing the right-hand side like that. But whether you were laughing at me or not for doing that, the point is that if you know something, if you know what to expect, your life is a lot easier. Okay, so like, how do I actually know that this graph doesn't turn around again? Okay, it turned around here. How do I know it doesn't turn around here or somewhere over there? Well, it's because I know what x squared graphs look like. So we're doing a little bit of practicing with nonlinear graphs in this section, but we're also going to talk later about how do you know ahead of time what to expect, because that lets you know when you've plotted enough dots.